everybody, in this video I'm going to teach you about data visualization. Data visualization is one of the most important skills you can acquire in computational social science, not only because you want to create, say, some compelling visualizations to share the results of your work, but also because visualization can be an indispensable tool for analyzing your data as well, particularly if you're working with really large data sets that are highly complex. So let's dive in. We're going to look again today at an example that we've looked at in previous videos, and that is data collected by Apple on the relative rate of requests for driving or walking directions after the onset of the COVID-19 pandemic. So if you see here on my desktop, I've got a file here called apple_mobility_data.csv. .csv is a spreadsheet format. It's very common, relatively primitive, but because it's primitive, it's also kind of no frills, which means it's very portable across a lot of different operating systems and programming languages. So we like to work with CSV. You'll notice though that it's not a .r data file, which is the kind of data that we've been working with in the past. So we're also going to add on a new skill today, which is reading in data from a spreadsheet. So I'm going to go ahead and open up RStudio here and load the tidyverse. Get rid of an old file here. Okay. Library tidyverse. The tidyverse has a nice package called read_CSV, and I can use this function to bring in a spreadsheet into R and create a data frame or a tibble out of it. So mine is on my desktop. I'm going to have to write out the file path here. That's the location on your computer where the file exists. You're going to want to take care to make sure you've spelled that exactly right. One capital letter, one missing underscore, whatever it is, will result in an error message. Okay, so I'm going to call this Apple Data. And here you can see in my environment pane, we've got the same data we looked at in our data wrangling video. Now in the data wrangling video, I explained that we have to do data wrangling or data reshaping and restructuring often throughout our workflow in computational social science. And that's definitely true in visualization. So suppose we wanted to create a visualization of the relative rate of searches for walking directions on iPhones across all these countries in this data set. Well, the first thing we need to do is move our data from wide format to long format. Remember, we've got all these columns in the data frame that describe different days and the relative rate of driving or walking direction search behavior, and we want to make those into a long data set. So once again, using techniques I described in the previous data wrangling video, I'm going to create a long data set, and I'm going to create a variable called key to key in our day. That's the variable we want to become the long variable in our data set. It's currently each day is a column, and we want to have one column that just has the date. And then we want to have another that counts the value within each of the cells for each day, and that's going to be called, let's call it mobility data. And remember that we then have to specify which columns we want to change from the wide format to the long format. In this case, the columns are named after the days, and in R we have to specify this backtick above the tab key in order to describe a variable name that includes numbers. Okay, so the first variable name is 2020-01-13. And I'm going to use my colon here to indicate that we want to look at the range, everything from that variable to 2020. I believe the last variable is 820. So let's go ahead and see if that worked. Now you can see in the environment pane down here, your environment pane may be up here. I put mine down here so that you can see some of the visualizations I'm going to produce a little later. And now you can see we have the days lined up as rows instead of columns, and then we have the mobility data by day for each country. Okay, that's great. That's exactly what we wanted. But now we still need to count or summarize the kind of average rates of mobility by country. And to do that, we're going to need to do a little more data wrangling. We're going to use some filtering and also some summarizing. That's a summarize is another function in the tidyverse, or dplyr, which is a part of the tidyverse, kind of responsible for data wrangling. So let's go ahead. We'll create a new object called data averages. And now I'm going to introduce kind of a newer skill as well. We just looked at importing data. Another new skill we're going to learn today is pipes. So pipes takes an object, like here, let's take the long data set we just made, and then we write this here. This here is called a pipe. And what the pipe does is pass whatever's on one line to the next line. So in this case, we'll pass the data set to the next line. And in the next line, we're going to want to, let's say we only want to look at walking data in this example. So I'm going to put a filter here. And instead of having to write out the name of the data set, long_data, I can just specify how I want to subset the data or break it into a smaller part. We only want to look at walking. Remember, I need 2 equal signs there. So basically, if I run this, you can see we've created this new country average object, but it's not quite what we want yet, right? It only has walking data, which is good. We filtered it, but we still want to summarize it. Now, just so you understand pipes a little better, we could have also rewritten this as follows. We could have just done filter long data and then transportation type equals walking. Now we did that in a previous video on data wrangling. Now, why might you want to use pipes? Well, the answer is kind of like convenience. Some people find it's a little easier to follow. Some people find it's harder to follow. It's really just going to be up to you whether you want to write out each line literally. Often if we want to combine multiple data wrangling commands together though, it is a little more convenient, and a lot of the kind of workable examples you'll find online will use pipes. So I want you to know what they are and kind of how they work. So once we've filtered, we've now only have the walking data, but now we need to aggregate the data. We want to, across all the countries, calculate the average rate of walking direction requests from the iPhone for each country. Now, you may have noticed in our data set that we have both regions and countries. So we've got like parts of the United States and then the United States as a whole. We want to look at countries as a whole. So I'm going to use the group by function. And that does just what it sounds like. It groups things by a variable. In this case, we have a variable called country. All right, I'm going to put another pipe, and as you can see, I'm passing the data set to the next line, and then on the next line, I'm doing the filtering. On the next line, I'm doing the grouping. And now I'm going to use the summarize function to create a new variable called walking average that's going to equal the mean value of the mobility data, that variable we created in the previous step up here. Okay, so this looks pretty good, but it's not quite going to work. Let's take a look. So if I run this, oh, I left out a pipe here. That's a really easy thing to do. So make sure you've got pipes at the end of every line that you want to kind of send something to. And but there's another problem, so let's look at it. Country averages, here's our new, now it's got 44 rows, that's great. It's got all the countries we were looking for, but you'll see there's NA values here. That stands for missing data or not available. In order to, why does it have those missing data? Well, it's because it's trying to calculate the mean using all the data in the data set. And if just one of those is missing, then it will return a missing value. We can add an option to our mean function here called na.rm equals true. And what that's going to do is it's going to say ignore the NA values, the missing values. Now, more broadly, adding an argument or kind of an option to a function is something new for us today too. What we're doing is saying calculate the mean, but do this other thing too. Anytime we have a function, we usually pass an object to a function, and then there's some options or things that we often call arguments. So here, na.rm is an argument, and we're saying turn that on. If I set it to false, then it would not remove missing data. So let's go ahead and give that a try. Let's try to open up our data set again here. And now we see we have our walking average calculated. So that's great. We're getting closer to building a visualization. In fact, we can now take the next step of using the wonderful ggplot package to build our first visualization. Now, ggplot does a lot of different things. We can do visualization in base R, but ggplot tries to make it both easier and more powerful and more easily controllable. So ggplot comes with the ggplot package, so we don't need to load the package, but we do need to use the ggplot function, which is kind of the core function in the ggplot package. Now, I'm going to take this country averages data frame that we created here, and it's down in my environment here if you want to look at it. And I created it by using that assignment operator up there. And I can't just run this. It just gives me a blank piece of paper right here. You can see in my plot viewing window. Now yours might be down here. I've rearranged mine so that you can see me at the lower right hand side of the screen here. But why is it a blank screen? Well, this is kind of important. ggplot works in terms of layers. So you can kind of think of it as starting out a picture and then adding one layer and then adding another layer and another until you build up into a visualization. If you've ever used Photoshop or Illustrator or other kind of Adobe products, you might be familiar with the concept of layering and adding layers on top of each other to make a visual. If you haven't though, it's fine. We're going to take some baby steps and kind of add on little by little. The first thing we need to do though is say specifically what we want to plot within the country underscore averages data frame. Now there's a lot of different variables in there still. What we want to plot is part of the countries, and we want to plot the mobility rate. To specify which part of the data set you want to plot, you have to use a function called AES, which stands for aesthetics. Now, I don't love the way this is named aesthetics. When I think of aesthetics, I think of like the font or the color. But in ggplot, aesthetics refers to the parts of the plot that are going in. So what's going to be on the x-axis of the plot? Or what's going to be on the y-axis of the plot? Which variables do you want to plot? That's what the developers of ggplot mean by AES or aesthetics. So here we want to plot the country, but we also want to plot the mobility rate. So I'm going to add an argument here, weight equals mobility rate. And that's telling ggplot I want to plot countries, but I also want to plot the mobility rate. Now I had to use this weight equals here because if I didn't, it would assume it was an x and a y coordinate. And that would make sense if we were going to say build a scatter plot where we had two continuous variables and little dots that describe the two values of the x and y coordinates. But here we only have one plot, and that's kind of why we had to use this weight option here. All right, now this is going to specify which part of the data set that we want to plot, but we haven't told it what kind of plot we want to do. And the first plot we're going to try is something very simple. It's called a bar graph. And all that is just bars that describe the values of the different stuff we're going to look at. Now, to add a layer in ggplot, sort of like a pipe, I press this plus button here, and then I add on another layer. I'm going to add on a layer called geom bar underscore bar. And that's going to tell ggplot that I want to create a bar graph. So let's go ahead and give this a try. Mobility rate. I used the wrong, we used walking average here. Just going to go ahead and fix that. Okay. So now you can see our first visualization. Not super impressive, right? You can kind of see maybe there's some country names down at the bottom here, but this is pretty ugly. So what's going on? Well, we told it literally what to do. We told it to put the country on the x-axis, and it's kind of, botched all the country labels. So maybe the first thing we want to do is to, instead of put country on the x-axis, put it on the y-axis. Maybe it'll look a little better. Let's go ahead and try that. So I'm going to come back up to my aesthetics here, and I'm going to specify this time that we want y to equal country. By default, it was taking the first argument to mean x. So I'm going to go ahead and write y. And now we can see it's flipped our chart, which is kind of handy. Now you can see we can read the names a little better. They're still not maybe the prettiest, but they're looking better. Unfortunately, we have an NA value up here. Now, if we went back to our original data set and looked, we would have seen that some of the rows had a missing value for country. These were things like territories or other kind of parts of the world that aren't, a country, but are somehow like a semi-autonomous region, I think. So if we want to get rid of those, probably the easiest thing to do would be to go back to our data wrangling step and add something like a filter up here where we created our country averages data frame. So I'm going to do another pipe, and then I'm going to filter again. This time I want to get rid of NA values on the country variable, which is what's showing up in our plot. Now, R has a function called is.na, and that lets me see whether any single thing is a missing value. Anytime I put an exclamation mark before something in R, it says don't do this. So I'm saying here, keep those things that are not missing for the country variable. Let's go ahead and give that a try. Okay. And here's our plot. I'm going to blow it up using the zoom button here so we can take a look. Now we've gotten rid of that NA value. It's starting to look a little better. It's still pretty ugly, right? We've got our countries labeled correctly, but down here we've got count. But really what we have is not a count, it's a relative rate of walking direction requests from iPhones. So if I wanted to say change the label there, I could add another layer. So now I'm adding a layer on top of what we've done already. I'm going to use this xlab function, and I can say relative rate of walking direction requests. And now when I go ahead and remake our plot here, you can see in my zoom window over here that now our x-axis says relative rate of walking direction requests. All right, it's still pretty ugly. Now we can get into some more kind of tweaks to make it look a little better. For example, in ggplot, we can add something called a theme. So one of my favorite themes is called theme minimal. I open close parentheses there. That's just telling ggplot to use a somewhat more minimal background. So we don't have that gray area anymore. It's a little bit more minimal, right? It's starting to look a little better. If we really want to make it pop though, maybe we want to add some color to call attention to where we want the viewer's kind of eyes to focus. I'm going to go ahead and make these bars blue by adding a blue text here within the geom bar layer. Let's go ahead and give that a try. Sorry, I need to add color equals blue. Now you'll see we've got a lovely blue color. Unfortunately, it's blue around the outline of the bar graph instead of the bar graph itself. If we want to make that bar graph, the kind of fill of the bars blue, we have to specify fill instead of color. Let's try that. Okay, and now it's starting to look a little bit more appealing. It's a little hard to read though because the data aren't sorted by their value, right? It would be nice to see what's the country with the highest rate of direction requests and what's the country with the lowest rate. And so to do that, we could do a few different things. We could create a factor variable in R, which is a factor variable is a type of variable which contains both labels and numerical values. And we could then determine the order of that factor variable according to the numerical values. The other way we can do it is to simply add another function within our ggplot called reorder. And we can say, take the y value here, and we can say reorder it by the weight of the walking average. So I'm going to go ahead and do reorder. I'm going to wrap this country here, walking average. And what I've done here, you can see how earlier I was saying how often we include instructions within instructions within instructions. And if you're looking at this and thinking, wow, there's a lot going on there, I can't quite follow every step, take a few minutes, maybe stop the video, try adding incrementally these different steps yourself, and see if you can kind of work through exactly what each thing is doing. It's a little bit tricky to follow, I realize, and it took me, honestly, a few hours before I became comfortable with the kind of general principle of layering. But even today, I have to look up stuff, and as you can see, I make mistakes all the time. Okay, let's give that a look. We reordered it. Now we have this, Much nicer visualization. We get to see that Taiwan, the United States, Japan, and Canada requested walking directions more often than other countries. And we'd want to dig a little bit deeper into these data to figure out what they mean. I believe what Apple produced here is a kind of normalized request rate that compared the pre-COVID request rates to the post-COVID request rates, so it adjusts for things like population size and things like that. But you can see we're starting to get something a little nicer. We've got an ugly y-axis here, so we could come on over here and add a y-lab and make that say country. And that would take care of that funny Y label we've got there. All right, so not too bad. A bar graph, a very basic kind of beginning graph in R. All right, now that we've had the chance to make a simple bar graph, let's try to progress a little bit and do something a tiny bit more complicated. Let's try to produce a line graph or a time series graph. We want to plot, in this case, say, Italy's data by day. We want to look at when people were moving around and when they weren't, but only in Italy. So to do this, we're going to have to use a date style object. So far we've just been working with either numeric objects or string objects in our videos here. But date objects are a little unique. If we take a look at the date variable or day variable in our data set, we see here in the console that it's a character variable, right? It's in quotes, and it has the year, the month, and the day. And though this makes perfect sense to us, and we could put it in order, to a computer it's just a little chunk of text. So what we need to do is find a way of telling R where the year is, where the month is, and where the day of the month is. So to do that, we're going to use something called lubridate. This is a package that allows us to transform a character variable into a date style object. Once it's a date style object, it will be easier for us to plot. We can, for example, use the x-axis for time and plot the frequency with which people are sheltering in place. Okay, so to do this, we're going to use the as_date function from lubridate. First, I'm going to load the library here. And then I'm going to take our long data day and simply transform it into a date style object using the as_date function. So now we have a variable that we can plot because it's easily ordered. But we still have a bit of work to do if we're going to find Italy and plot, say, just the walking data from Italy, the walking directions data from Apple. Let's take our long data, pass it to the next line via a pipe. Then let's filter by country. I'm going to say country equals Italy. And we only want to look at the walking data. So let's use transportation type equals walking. Okay, that's great. That gets us part of the way. We now know that we're only looking at walking data and only looking at Italy. But it turns out that there's also data that is aggregated by region. So we really want to look at the national level by day. So we're going to do another group by, as we did above. Above we grouped by countries. Here we're going to group by country and day, and that'll allow us to aggregate the total rate with which people are requesting, in this case, walking directions by day in Italy. Grouping by country and day, these are variables from our data set long data. Now we're going to use the summarize function once again. I'm going to call this walking average to describe the daily kind of average of walking data requests. And we're going to make that new variable equal the mean of our mobility data variable. And once again, I'm going to add a function to this, an argument to this, which is na.remove equals true to remove the missing data. Okay. So running that, we saw the output in the console. We probably want to save it as another kind of data set here. I'll call it Italy data. And now we can see Italy data has appeared in our browser here, and we have days and the average number of walking requests relative to the pre-COVID rates. Okay, now we can finally do some plotting. So let's use ggplot. We're going to bring in our Italy data. Now we're going to specify aesthetics where x, the x-axis in our plot, is going to be day, and y is going to be the new variable I created above, walking average here. Okay. Now we're going to add a layer just like we did before with the bar chart with geom bar, but this time we're going to use geom line to produce a line graph. Let's take a look. So here we have a nice, neat plot of the average number of requests for walking directions from iPhones by day in Italy. So using some of the steps we did before, we could, for example, retitle the x-axis, retitle the y-axis, maybe make the overall theme of the plot look a little cleaner, maybe use the minimal theme like we did before. So for example, we could do plus theme. Let's do, instead of the minimal one, let's try the black and white theme. That's another nice one. And let's change our y-lab to relative volume of walking direction requests. And there we see a slightly prettier graph. And again, we could go deeper in order to improve the aesthetics, change the font, maybe change the size of this label here, axis label, so that it fits a little more nicely, and so on and so forth. Okay. Now that's cool for Italy, but suppose we wanted to do some international comparisons. Suppose we want to compare Italy and Spain, for example. Well, one way we could do that is up in our filter command up here. Instead of just specifying Italy, we could specify Italy and Spain. One kind of convenient way to do that is to pass a vector of country names to the filter command instead of just one. So remember, in R, a vector is created by writing C open parentheses and then closing them at the end of the vector. And so I'll add Spain here in parentheses because it's a string variable or a character variable. And I'll now retitle this Italy-Spain data just to keep things clear. And now in this data set here, we have data for both Italy and Spain. So if I come down here, I could pass now this new data set that we created to ggplot, and we could go ahead and plot this. And it's still pretty messy as we kind of look at it here. You'll see we've got a lot of different trends going on. So one thing that we could do to kind of clean this up is to try to pull out each country. So here we can use a new kind of aesthetic called group. Group is going to determine which parts of the data frame are plotted. And let's also add some color here. See how this looks. I'm going to blow it up so we can see it a little more clearly. And here now we're seeing a nice plot of the relative frequency of requests for walking directions in both Italy and Spain. Again, we could go deeper, we could change the color of these lines, we could add some trend lines. These are all kind of more advanced topics, and I think once you get the basics of working with layers and figuring out how ggplot works, you can dive into the documentation, do some good Google searching for things like how to make the x-axis bold or the y-axis bold, whatever you want to do, and you'll see more often than not, it's just about adding another layer. But there's one more skill I want to give you before we close this kind of basic intro into visualization in R and ggplot, and that's the concept of a facet. A facet is simply a way of breaking a plot into multiple plots. So in this case, instead of visualizing both Italy and Spain together in the same plot, we want to put them in different plots. And really this might be most helpful if we had 3, 4, or 5 countries, but I just want to show you how easy it is to do this in R. All we have to do is come up here and add another layer that's called facet wrap. Facet, again, stands for multiple plots within a single plot frame. Within this facet wrap function, we're going to use the tilde key that's above your tab key on your computer. And that tilde in R typically means explained by. So everything to the left of something is explained by everything on the right. That's kind of a typical R convention. And so if I write country here, it's going to use country to organize those different facets. And now, when we run that, we see a handsome facet graph here for both of the two countries. Now again, we've only started to kind of scratch the surface here. You can go much deeper in ggplot itself, but ggplot is only the beginning of many, many wonderful packages in R for visualization. Everything from network analysis to dynamic visualizations to really interactive visualizations, R can do it all.